Protection for free speech is actually very, very rare globally. No country has the protections that we have here, and we're constantly complaining about them. And what we keep talking about is emerging markets. Basically, all of these people coming online, they're coming online almost entirely globally, and they're coming online in places where the infrastructure is not meeting demand. So when we talk about a lot of these people coming online with a cell phone, they're not online 24 hours a day. Their connection isn't reliable. Sometimes they still go to places that are offline. And everything that we do for building applications now doesn't work for these users the majority of the time that they use their applications. So let's get into this a little bit. So let's think about like today's responsible application model. Like if you're a good person, how do you build applications today? So your users connect to a cloud service over TLS. You don't use TLS, you're a bad person. Go outside. That's really important. Just do it. Just do it. It's easy. Just do it. But those cloud services authenticate our users, and then those cloud services store that data private to that cloud application, but not private to the infrastructure provider. So I authenticate you, and then I want to give it to somebody else. My application logic is responsible for not giving that to anybody else. But my service reads it out of the database all the time, right? So this model is like hopelessly optimistic, right? We can't write data if we can't authenticate, which means that we have to have this constant reliable connection. We can't have anybody block anybody's connection to that service. So if some of your users are in China and they decide not to like your service, those users are just blocked because you didn't think about this. And it also assumes that infrastructure is free from surveillance, which is funny because we know that that isn't true, right? Like we continue to take private data from people and then we store it in a database that we know the government has access to. We actually know that if you build an application for AWS, you won't ever get a letter from any surveillance operation, or you won't even get it from law enforcement. All of those national security letters, any subpoenas, they go directly to Amazon with a gag order. They can't even tell you about it. And how much money do you think that they're going to pay for lawyers to protect your users and your data when they can't even take credit for it? Like, I'm willing to bet they're going to spend about $40, maybe. So yeah, so like this is just like not a way to protect our users' privacy and our users' data today. Like we know this, we just don't have any way around it. So as we start to think about these use cases, and really we're in like day zero of actually building reliable applications for these users. I'm not saying that we have it worked out yet, but just think about these different types of users. People with unreliable connectivity, with restricted connectivity, people that have local peer-to-peer networks so they can contact their peers and maybe get out that way, and people that have to be offline. All of these use cases have the same first problem. And the first problem is that they lose that authority. They lose this central point of authority where all the application logic is and all of the authentication logic is, right? So here's an example of what I mean. So if I want to send a message to somebody else through a cloud service, I essentially authenticate to the cloud service, hand it to it. That person authenticates to that service and hands it back to them, okay? When I get this message, how do I know that it came from that person? Because the service told me that it came from that person. It gives me no information other than like it came from me, so you have to believe it, right? If I put something into a cloud service and I say that it's from me, every user that gets that and it looks like it's from me, we just trust that this cloud service gave us the right information. So where this falls over is like, I have some information from me. I want to send it out to everybody. I want to put it on Twitter or whatever. But I don't have a direct connection to the internet, right? So either I put it on a USB drive and hand it to somebody, or I connect to a peer-to-peer network and I sync it out, and then those people connect to other people. So we're going to go through an intermediary, right? And, oh my God, it's Tom Cruise! So we're going to go through Tom Cruise. We're going to hand them our data on a disk. It's called Ghost Protocol. And then I'm going to get this data from Tom Cruise, right? The problem here is like, how do I know that this really came from this person? And like Tom Cruise gave it to me. Like if Tom Cruise showed up at your house and was like, I have a message for you, would you really believe him? Probably from Zenu. So anyway, this is like a real fundamental problem you have when you start to go into all of these use cases, okay? Like peer-to-peer, offline, everything. Even unreliable connections, where we need to put data into places that are not just this one cloud service. And wherever we park it, it's going to get tampered with, or it can be tampered with. So the solution for this is cryptographic signatures. It's a really easy concept to understand. Basically, a person has a public key, and they generate a hash of this data that they say is from them. And you can verify cryptographically that this person hashed that data and that it was not tampered with and that it really came from that public key. So all of a sudden, like, oh yay, I can send this data to Tom Cruise and he can give it to me and I know that it actually came from this person. Thank you very much. In fact, we can shove this into a database in China and we know that it was not tampered with because it's cryptographically signed. This is like a really great concept, but think about this. Whenever you go to build an application today and you start storing data in AWS or you start handing it off to cloud service, you're not signing it. Like, you're not even associating people with public keys necessarily. You're not ever thinking about this. You're just assuming that I own all of the application logic, so I own all of the authentication logic, and you can trust all of this data that you're getting in. Similarly, if you want to send a message to somebody, so we want to thank Tom Cruise for sending us this data, so we're going to send him something. We can actually encrypt it. We can say, like, oh, nobody can read this now. So now, like, when I send it through intermediaries, they can't read the data. As long as we, have these public keys around, we might as well just start encrypting data if we're sending it from one source to another. In fact, if we send it, we can literally send it through database in China and they cannot read it. This also solves our problem where if we're just shuttling data from one user to another and we're worried about our infrastructure provider being surveilled on by the government or getting NFC letters or even being compromised by a hacker, if we can't read the data in our cloud services, it can only be read from one point to another. We just don't have that problem anymore. It goes away. All right. Is everybody with me? Who's with me? Yeah. All right. So one last thing, you're not going to like it. This is how Scientology works. You're all in now. I deem you level 6 clear. All right. So why are we building applications this way? It's really simple. We build applications using an immense amount of software infrastructure. The reason why everybody here can get an idea in their head and go and knock it out in a weekend is because there's like almost 500,000 modules in NPM that do a lot of work for you. And Lori Voss is here. He hand delivers those to you when you install them. Yeah. When you hit NPM install, he has to type yes on the computer and open. But no, like, so we have a lot of software infrastructure that will help you build applications in the traditional manner. We don't have a lot of software infrastructure to help you with this. And what we do have, we're not even sure if it's the right stuff yet. I mean, something this basic, right? I've written, all the stuff we just talked about, I've written libraries to do that. In fact, I've written 2 or 3 libraries to accomplish every step in that, and I'm not quite sure that I nailed it yet. Veros is here. He wrote WebTorrent. He's also written that a bunch of times. You shouldn't use his modules either. Not because they're not great, but we don't know that we've nailed this yet. We're not even sure like which crypto algorithms we should necessarily be using because we have to make them work in the there's a bunch that work in the browser, but like which ones are better or safer or whatever. How do you associate a person with a public key? This is like not a solved problem. We're like still figuring out like all the workflows around this, and we don't have the software infrastructure built for it yet. We don't even have basic stuff like RTC signal exchanging yet. Like everybody who does peer-to-peer apps, and I know them like all personally because there's only that many building peer-to-peer apps on the web right now. All of us have built our own signal exchanging mechanisms because we like haven't really figured out what the best one is. So what I'm getting at is that if you're the kind of person that wants to go out there and build the next library that everybody uses, the next library that like really impacts people, this is a really good space to be in. This is like where a lot of people are doing really cool new cutting edge work, and there's a lot, it really is a green field. And it's addressing problems that we have right now, not some future tech. So if you're that kind of person, if you want to play with some new stuff, come and talk to me or Feros or get online and build some stuff together. Yeah. That's about it. That's all that I got. Thank you very much.
The Mikeal Rogers up in there. Whew. I knew he was gonna come here and drop some next level shit, and he did, Although I have to say, you could have summed it all up by just like throwing up some like screenshots of Matthew Lillard shouting "Hack the Planet." They're trashing our rights. You know, good old Emmanuel Goldstein.